guys, so in this lesson, we're going to talk about the parabola. The parabola looks like this U shape right here. So it's very unique, okay? Now, the x-intercepts are the same regardless of the function. The x-intercept is going to be the points at which the parabola crosses the x-axis. And we know this because we did this with lines, okay? The x-intercepts are going to be the point at which the parabola crosses or touches the x-axis. Right? If they exist, the x-intercepts are going to represent the roots of the quadratic function. That's going to be the value at which y equals 0. So when we look at this parabola, where is this crossing the x-axis? Exactly, it's going to be right here. So it's going to be this one right here, and it's going to be this one right here. All right, so if you'll notice and follow the dashed line, pay attention. You'll see the dashed line is trying to tell you which ones are the x-intercepts. So the x-intercepts for this problem are -2, 0, and 5, 0. Okay. The y-intercept is something else that we're familiar with. The y-intercept is that place where your function crosses the y-axis, okay? So we're going to write the y-intercept is the point at which the parabola crosses the y-axis. Okay? And if you follow the dashed line, it tells you, yeah, that is right here. It's actually -5, right? Oh, -3. All right, so this one happens at 0, -3. Okay. X-intercept, y-intercept is nothing new. And this is where x equals 0. So an easy way of getting the y-intercept is sometimes just plugging in x equals 0 into the function. And if you're in standard form, then it's going to be very easy. It's just going to be the constant, okay? Now, the vertex is the most important point on the parabola because it's where it changes. It was going up, it starts going down. It was going down, it starts going up, okay? That's the vertex. Can we all say vertex? Vertex. So if you look at a parabola, right, and if the parabola is opening up and we say this is up, you see how it's making a U? So this is when it opens up. The vertex is going to be right there. It's that point, that lowest point. So in this case, it's the lowest point. So we call it, you know, that we say that it has a minimum. Okay. That's also the vertex. The vertex, if the parabola opens down, is going to be up here. And so we say this parabola would have a maximum, okay? All right, so let's answer these questions. If the graph opens up, the vertex is a minimum because it's the lowest point on the parabola. If the graph opens down, the vertex is a maximum. But for that, you need to be able to recognize them. And I gave you a hint. Opening up is when you make the U shape up. And then so it's basically the direction that the arrows are going. Okay. The vertex is a point on the parabola. No, on the axis of symmetry. And we'll talk about axis of symmetry next. And when we look at this graph, the ordered pair that is the vertex, and you know, you can follow the dashed line. It's an ordered pair. So this point is 2, -6. All right. So what we're doing here is learning vocabulary. Afterwards, we're going to learn how to do all the calculations, okay? All right, the axis of symmetry is going to be a line. And this line is going to slice the parabola in half. So in this case right here, this dashed line, vertical line, is the axis of symmetry because it creates two equal halves. Remember, my parabola is the blue one, right? The axis of symmetry is going to go straight down the middle through the vertex as a vertical line. All right, so let's fill this in. The axis of symmetry is the vertical line that goes. The axis of symmetry is a vertical line that goes through the vertex of the parabola so that both the left and the right sides are symmetric. Or two equal halves. Keelan, number one behavior that puts you to sleep. On this graph, the axis of symmetry is x equals 2. X equals 2. So it's a line. So you have to say x equals 2, not just 2. All right, domain. For this parabola, since there are no constraints, this is not representing some real world problem, we say that any x is going to work because the parabola goes on forever on both ends. So the domain is always equal to all reals. All right, we say that by doing the symbol that is all reals, and sometimes we say this by negative infinity, positive infinity. Now the range is the y values, and the one that's going to determine the range is the y coordinate of your vertex. So if the graph opens up, that's up, we say that y is greater than or equal to whatever the y value is of the vertex. If the graph opens down, read? Oh, I thought you were telling me something. Okay. If the graph opens down, then we say the range is y is less than or equal to whatever the y value is of the vertex, okay? So we're going to do an example. The vertex in this problem was 2, -6. Do we agree?
Yeah.
What's the y value? -6. And did this parabola open up or did it open down? Opened up, right? So you're going to follow the instructions here. If the graph opens up, the range is y greater than -6. Greater than or equal to -6. All right, so looking at the graph, why does this make sense? Let's look at the graph. Here's the vertex. Here is -6. And the y values go up like this. The blue curved line doesn't have y values that are less than -6. All the y values are -6 or bigger. Clear? That's why that's the range. All right. Any questions on the notes? X-intercepts, Y-intercepts, vertex, axis of symmetry, domain, range, Kershaw. All right, flip over to the back side of this. All right, so this one just has all of your definitions. There's three things in here that I want to highlight. A quadratic function, it's in this form. It has a highest degree of 2. Okay? So now we reviewed this earlier, so we're better able to identify when something is quadratic. Parabola is the name of the graph, right? It's either going to go like that or like this. X-intercepts are going to be where your parabola is crossing the x-axis, y-intercept where you're crossing the y-axis. Vertex is either the highest point or the lowest point. The highest point would be in this case. Please draw the diagrams so that the text makes a little bit more sense when you're going through it. Okay, that's what we mean by the highest point, by the lowest point. Axis of symmetry is a vertical line, up and down. It goes through the vertex. Okay? There's only one vertex, so there's only one axis of symmetry. There are three forms to your quadratic function. There's the standard form. Julene.
I have a question about the
Uh-huh.
Okay, so the highest is the point that you circled, right?
Mm-hmm.
The lowest is the point.
Yeah, so that's the vertex.
Okay.
Standard form is when you have no parentheses. Please write it down. Is when you have no parentheses. Whether you have 3 terms, 2 terms, or 1 term. Notice that the definition, it simply says no parentheses. You can be a 1-term parabola, see? You can be a 2-term parabola, see? You can be a 3-term parabola. Okay? It's not about the number of terms. Obviously, you can't have more than 3 because it's quadratic. Quadratic is the highest degree. Now, that's standard form. Side conversations in the back. Okay? Intercept form. Intercept form is this one, and it's when you have parentheses and raised to the first power. All of your parentheses are going to be to the first power, whether you have 1 set of parentheses or 2 sets of parentheses. So you know that you are in intercept form, right? So that could be something like this: y equals x plus 2, x minus 3. You see, you have 2 sets of parentheses, but all of them have an outside exponent of 1. It's an understood 1. Or you can look like this: y equals 3x times x plus 2. You only have 1 set of parentheses, but it still is being raised to the first power. Now, these don't look like they have a degree of 2, Ms. Medina, but they're still quadratic because the implication is that you're going to multiply. What is x times x? It's quadratic. Same thing here. 3x times x, 3x squared, so it's quadratic, okay? McMichael, what did I say about your echoes? Vertex. Vertex form is this one, and I found a mistake on this, so I'm going to zoom in. All right, everybody, right here. See where it says x minus h inside of parentheses? There should be a 2 right here. All right? There should be a 2 there. Please fix it, because that's how you're going to tell them apart. And so for this one, I would say that you have parentheses, 4th period. Fourth period, just because you talk quietly doesn't mean that you're not talking. Squared. So you're saying, well, how am I supposed to tell them apart? I just told you how to tell them apart. Okay? And you do have to be able to tell them apart, because I will ask you, so what form are you in? Because that's going to determine which solution process or which solution steps you're going to take. So one of the quizzes that I'll give you is identifying which form your equation is in, okay? All right, those are the main things here. Now, do me a favor, quietly answer this one. 2, 3, and 4. You have 1 minute. What I say quietly? All right, time's up. So what did you guys say was the x-intercepts? Okay, what did I say? Whether you're talking quietly or not, you're still talking. I still hear it, and it's disruptive to the lesson because now I'm not teaching. Fourth period, we are going to get this talking under control. Yes, question. Okay, so what do you have for the x-intercepts? All right, thank you, Jamarian. Good job. Any questions on those? Did you get them right? All right, now the y-intercept. Okay, Dwight. Exactly, 0, 8. Even though it's not written there, that is the y-intercept right there. Okay, because we're crossing the y-axis. For the vertex, who's going to share? Kaladu. -1, 9. Correct. That's the vertex. And is this a maximum or a minimum, Kaladu? It's a maximum, okay? Axis of symmetry. Who's sharing? Raise your hand. Keelan, you moved your hand. Don't put your hood on. No hoodies in class. So what is it? X equals? Use. Okay, McMichael. -1. Yes, because this is the vertical line that slices the parabola in half, 2 equal halves. Now, here's something interesting. Pay attention. The axis of symmetry is always going to be the x value, and the max and the min is always going to be the y value. I know you're taking this time to write this down. If you know the vertex, you know the axis of symmetry, and you know the max or min. Say it again?
That's the part I was confused on, but I got it.
There we go. All right, so standard form, intercept form, and vertex form, you're not to know this yet, so I'm going to go ahead and give you these answers. They gave us an equation right here. Which form is this? This one is standard. What's the trick that I told you to be able to tell it apart? No parentheses, there we go. Now, there's no way for you to know this, but for intercept form, I'm going to use the x-intercepts. I'm going to use the -4 and the 2. Watch. It's going to be y equals x plus 4, x minus 2. Okay? And so by using the x-intercepts, we're going to be able to write the intercept form of the equation. The vertex form, we're going to use the vertex. And the vertex in this case happens to be, where do we write it? -1, 9. I'm not explaining how to do it just yet, okay? I'm just telling you that we are going to be able to do this. Just with having the vertex, I can write the vertex form. It's only the first one changes sign in this one. And then, so this is, we're not doing this part right now just yet, the equivalent forms, okay? But that's literally how we go about writing them. And it can be simple as long as you know what information you need for each. Okay? So these are examples of, you don't have this in your packet, so please look up, of real life parabolas, real life phenomena that we can model with this, with quadratics, like water flow, and that has to do with gravity. Bridges, the beds of rivers, design, yeah. Rides, Six Flags or Disney World. Throwing a ball into the air. This has to do with gravity, but that's the reason why, because the Jalan, the gravity relationship is quadratic. So I ask that you please stop talking and pay more attention. Architecture. Modern architecture. Light. Does everybody see the parabolic shape right here? Yeah. There you go, see? Natural phenomena. So it happens everywhere, and that's why the mathematics had to come about, so to be able to describe it. Because you may not want to describe it, but human nature wants to describe natural phenomena. All right, the next page. Next page. I thought I did the wrong one again. All right, let's see. I'm not going to zoom in more because you guys have it in front of you, right? And I want to have the graph in this, the zeros. I'm going to give this to you again. Please write it neatly so that you can use it as a reference. The zeros are the x-intercepts. Okay, zeros are your x-intercepts. So when you're looking at the parabola, you're looking at where you're crossing the x-axis. And in this case, it happens at -4 and it happens at 0. Okay, no parentheses because I'm not trying to imply that this is an ordered pair. In fact, I can put them in brackets. It's -4 and 0. Axis of symmetry is the line vertical that cuts the parabola in 2 equal halves. So in this case, it's going to be this one. So it's x equals -2. You see, because it's going through -2. That's how we name vertical lines, x equals. This is a maximum. And the maximum happens at 4. Right? That's the highest y value. Now, coincidentally, the vertex is which x value and which y value. It's what? -2, 4. Just like I told you before, this is the axis of symmetry, and this is your max or min. Clear? Just like I told you before, the first one, the x value, is your axis of symmetry. Notice that there's the word x is on the word axis. All right, so let's do this one a little bit. Let's skip this one and let's do 3. All right, here we go. In number 3. What are the zeros of this function? Once again, go back to number 1, and the zeros are -3, and +3, right? This is not an ordered pair because it's not in parentheses. This is in brackets, which is just giving you 2 elements. Let's do the vertex. Let's do it differently this time. What's the vertex? It's 0, -9, right? And I already know that this is going to be axis of symmetry. And this one is going to be max or the minimum. You only have one of each, okay? So just by knowing the vertex, we know the axis of symmetry. X equals 0. And it is, see? The y-intercept is the y-axis of symmetry. The maximum here, the minimum is -9. Because if you look at the y-axis, the parabola only exists, -9 is the lowest point. That's why it's the minimum value. All right, this one is special. How is number 2 different from 1 and 3? Yeah, it's only touching the x-axis, it's not crossing it. See how it bounces back up? All right, so let's look at this. So how many zeros do we have? How many x-intercepts? None of them. We have one of them. I don't know why y'all said 2. -2. It's to the left of the y-axis, so they're negative numbers. What's the vertex of this parabola? Come on, people, what's the vertex? Guys, the vertex is an ordered pair, an x and a y. It's a point on the order. There we go. Now, just from your vertex or from the graph, what's your axis of symmetry? If you just put -2, it's going to be wrong because it's supposed to be a line. And so it has to be x equals -2. Don't say I didn't warn you. Here it's going to be a max or a min. And y is going to be equal to 0. Why? Because right here is the lowest point of your parabola. The parabola exists there. Clear? What's the lowest y value? 0. You see? So 0 is the lowest point. All right, so some of you guys are following along and some of you guys are not. So we're going to try this. Answer the questions for 4. Go. What are you supposed to be doing? Answering questions for 4. In fact, why don't you just answer all the questions on the paper? And the next page. Because I was talking to Taver, not to everybody. Come on, people, you're on question number 4. All right, time's up. All right, so let's do this quickly. What did you write for the zeros? -5, -3 in brackets, which is not an ordered pair. Are we clear? What's the axis of symmetry? There we go. -4. Is this a maximum or a minimum? And y equals what? Yes, right here, see? Y equals 1. Now, what's the vertex? Negative 4, 1. Negative 4, 1, not negative 4, 0. Which makes sense because what did we say was the axis of symmetry? And what did we say was the maximum? So once again, this is the axis of symmetry, and this is the max or the min. Please try not to burp out loud in class. It's very uncouth. We will. All right, let's try this again. And I can't force you to do individual practice. Are we clear? But you have to try to prove to yourself that you can get it on your own. So now, number 6, go. Please work quietly, no side commentary. Keelan, stop sleeping. Okay, what do you guys have for the zeros of this parabola? Ah? 1 is here, and 3 is here. Oh, no. No, you have to cross or touch the x-axis. Exactly, so the answer is?
That's why I asked her to do 6. That's what I said. I said 9. Then you start putting it down.
Okay. Shh. All right. Honestly, what did you put for the axis of symmetry? X equals 2. Right? It's right here. It's the vertical line that goes through the vertex. X equals 2. All right. Is this a maximum or a minimum? And what is your y value for your minimum? What's the y value at the minimum point? 5. See right here? 5. Clear? And what is your vertex? All right, the table, you're having a conversation, 4th period. All right. So, how is it? It's good? All right. Answer number 7. Oh, you know what? It's almost 3 o'clock. Let's do this. 4th period. 4th period. When your teacher is talking to you, don't talk, okay? Because then I have to scream louder so you can hear me. All right, so what we're going to do is going to move on to IXL. And I would like for CC1 to be completed. You also have CC3 and CC domain and range. Yeah. Okay. 4th period.